in the Big Data Analytics course. So, first of all, what is Google Dremel? Google Dremel is a system for interactive analysis using a SQL-like query language over big data sets. The important thing in here is the interactive part. It processes all the information from big data sets almost in real time. It is capable of running aggregation queries over trillion rows table in just a few seconds. In order to implement this solution, Google has created a column storage representation system for nested data and also an execution tree of servers for processing the queries. That's the internals of the system. That is widely used into Google for several things like processing spam or tracing the usage of applications into the Android market. It is very interesting to compare the Google Dremel approach against the previously existing MapReduce approach, also created by Google. While in MapReduce we have a bunch of mappers and reducers that are jobs that we need to execute and wait until they finish, this takes minutes and most of the time hours. It is a batch processing system. While Dremel, I've mentioned, is an interactive system. It's much faster and able to process a big amount of data in seconds. It does not translate the queries we do into mappers or reducers as it happens in Hadoop or any other MapReduce solution. Also, Dremel offers us a query language quite similar to the SQL we use in relational database. While in MapReduce initiative like Hadoop, we don't have a language. We have to use extra layers like Hive or Pig in Hadoop, but it is still a batch processing system. Also, I would like to mention that the MapReduce implementation, mainly Hadoop, requires a lot of effort in terms of managing, configuring, and setting up the infrastructure. While in Dremel, the main implementation, BigQuery, is pure cloud-oriented implementation where everything is maintained by Google. We don't need to set up or to configure any infrastructure. This made some people to claim that probably Hadoop is an old system and it's not enough for facing the real big data requirements, but the truth is most of big data companies has invested a lot of money in Hadoop similar solutions. So what we see in the market is that both solutions, near real-time solutions like Dremel and more batch processing solutions like Hadoop are complementing each other and adding extra layers, and probably at the same time some companies like Google or Facebook will keep moving towards new solutions. Regarding the implementation, we already BigQuery. We already mentioned BigQuery. We will see now an example, and we also have an open source implementation, but still in early phases, so it's not at the same level of maturity that BigQuery, but that it has the advantage of being the open source alternative, so we can use for whatever we want, and we can even have the source code. So let's take a look. So here we are. We start in the API console screen. We have created a project. We can see that in our project we have activated the API for BigQuery. To activate this, we only need to go to the service option and to activate those APIs we want to use. I also activated, for example, the Google Cloud Storage for moving some data to the BigQuery. We can move also directly. So since we have activated the service, we have the option in here. Before continue, it's very important to understand that if we activate any of this service, we may be charged by Google. I mean, they will ask for a credit card. But just for testing the BigQuery, we don't need it. There are some sample datasets as part of BigQuery that we may use for play with the tool, for do some experiments, and we don't need to pay anything. So while we enter in BigQuery, we have different channels to work with it, like a web interface, command line tool, or several APIs. Let's do it through the web interface since it's very clear for the examples. So here we are. We have different data sets. So let's take the public one that has no any charge for use it. So for example, this data set that is natality, that it contains in theory all the people who has born in the US, I guess, since 1940. So here is the schema of the table. You see we have only one table, while in the relational databases we try to normalize as much as possible. In here we do the opposite. We try to denormalize as much as possible, so we have all the information in one single table. We can take a look to the contents of the table, and of course we can query the table. So let's, for example, query how many people has born since 1980. We may select any field from the schema. Let's run the query. So here is the answer, a lot. And what is interesting in here is to see that we have been able to process more than 1 gigabyte in just 1.5 seconds. So here we can see one of the characteristics of the Google Dremel approach. It's an interactive system, not a batch system. It is interactive. So it does not translate the query to mappers or reducers or any other kind of job. They solve the answer directly, the query, in a native way. We get a really fast time response in comparison with a Hadoop approach. Okay, so let's do something else. Let's do a more complex query now with some fields. Let's go back to natality field. Let's query, for example, the state where the person was born, it's male or not, the race, what else? Well, I think that this may be fine. And let's query those people who has born in the 76 April and 20th of April, my birthday. So here it is, almost 4 gigabytes in 2.4 seconds. Another thing that is interesting to know about the BigQuery solution that stores all the information in a column-based organization is it only queries those columns that we're asking for. I mean, if now, for example, we drop those fields and we repeat the query, you see, instead of the previous amount of data, we are only now processing 2.93 gigabytes. Now let's see how we can upload our information just in case we want to create our own datasets. So for this example, I have downloaded some information from the Hubway, that is the bike sharing system of the city of Boston. Here we are. Imagine that we want to upload the list of bike trips that took place during 2012. So I want to upload, in this case just a part of this file, to do some query with it. And I will do it using the Google Cloud Storage. So we are again in the Google API console. I have selected my project and I go through the Google Cloud Storage. It provides me different access methods, so we will use the online browser, that is the easier one for this example. Let's create a new bucket. This is like Amazon S3, you will see it's very easy to use, and we can upload just doing drag and drop. So as you can see, I uploaded a very small file just for the example. Now that we have the information in the Google Cloud Storage, I may return to my BigQuery system, and I may import any new file. So first of all, we have to pick the dataset. I already created a dataset called Halfway. Let's call this short trips. So I have to check what is the root of the file into my dataset, into my bucket, I mean. I'm uploading it as a plain file. Previously, we have to define the schema of the file. All the columns we will find into the file with different types. Of course, we have to use the BigQuery types. So in this case, for example, we have several columns like the trip ID, the status of the trip, finished or not, how long it takes, start date, start station, end date, end station, and so on. And I don't have any header row, so we can proceed. You can see we have one job running, uploading this file from the Google Cloud Storage using this schema. Okay, here we are. So here is the file I already upload with the schema, with the ID, station, status, duration, and so on. I can see some of the content and I can make a query. Okay, so we have 120 trips with more than 30 minutes. From a total of 2,000 trips. So it has sent since 30 minutes is the limit. After that, you are charged for using the bike. So we see that most of the bike trips only take less than half an hour because that's the free limit, or the limit of a free ride. So that's what data scientists call knowledge of the domain. So we saw in this example how to upload the information and query the information. In the previous one, how to query information using the simple data sets. As a conclusion, you can see that this is a very fast and interactive system, and that it processes only those columns that you really need to process.